let's do some examples of counting to find probability. So when I say counting, we can use the idea of factorial, we can use the idea of combinations, and we can use the idea of permutations. Right, so that deals with the counting. Now remember, when we're talking about probability, we are talking about what we want to have happen. How many options are there over the total possible? So keep the idea of what probability means also. All right, let's do the first one. A company needs to send 4 employees from a team of 20 to a conference. The team consists of 13 specialists and 7 generalists. What is the probability all 4 chosen are generalists? Okay, so now, again, probability, think about what do we want over total possibilities. Now, I want 4 generalists, but I have 7 to choose from. So I have 7, choose 4. Because out of the 7 generalists, I want all 4 to be chosen. That's what I want. Now, the total possible is that I have 20 team members, so I have 20 total possibilities, and I want to choose 4 of them. So the denominator is if I have 20 people and I'm choosing 4, how many possibilities do I have? Notice we're using combinations because we don't care what order. I just need 4 people. I don't care who's chosen first and who's fourth. You're all going to the same conference. Calculating this. 7C4 gives me 35. And 20C4 gives me 4,845. To reduce this, I'm going to divide both the top and the bottom by 5, and I end up with a fraction of 7 over 969. That is the probability of this happening, reduced fraction. If you change this to a decimal, you get like 0.007. Okay, let's do another one. A radio station is holding a contest to give away concert tickets. The 3rd, 45th, and 70th callers will win the tickets. Notice, because there is a specific order, order matters. That tells us we're going to use permutation. Now, 120 callers is the max allotted in the time period given for this contest. So 3 different friends plan to call in to try to win. What is the probability that they all 3 win tickets? Okay, what do we want over our total possibilities? So let's think through this. What do we want? Well, we want our 3 friends to win. So if I have 3 friends, how many options do we have for somebody to finish 3rd? Well, we have 3 options because all 3 of our friends could finish 3rd, right? Okay, so let's say that friend number 1 finishes 3rd. Great. How many friends do we have left to finish 45th? Well, 2, because 1 has already won. Great, so we win that one, and then we just have 1 more friend that needs to be 70th. So we're using the idea of factorial. I have 3 friends, right? So our numerator is going to be 6. We have 6 total ways for these 3 friends to finish in the 3rd, 45th, and 70th callers. So what is the total possibility? I have 120 callers, and 3 positions matter, right? And order does matter because if you're 3rd, you win. If you're 2nd, you're just a loser, right? So because the order does matter, we're using a permutation. So 120 P3 gives me 1,685,040. So if we want to reduce that, they do both divide by 6, and we end up with 1 over 280,840. So when you're thinking through counting with probability, remember what probability is, what we want over the total possible, and think through what are all the ways that I can make whatever happen, right? Do you need a factorial combination of probability? Does order matter? And think through. So if you're calling for a contest, does it matter if you finish 1st or 2nd? Absolutely. Well, in this case. So if order matters, permutation. If order does not matter, as in our first example, you use a combination.